Good morning, students. We will continue that previous class. In that previous class, we were we were discussing about the objects, two kind of objects, real object and virtual object. Thereafter that we started the discussion of image. There I said image is nothing but the intersection point of reflected or refracted light rays. Those images are again of two types. One is real image and another one is virtual image. How we have to identify which kind of image it is? See here. Look on this diagram of real image. Here I have taken a biconvex lens. Lens means an optical medium bounded by two spherical refracting surfaces. Here lens means it is optical medium bounded by two refracting surfaces. Refracting means what? When light, see like this type, it is a biconvex lens. This side curved and this side also curved, I mean spherical surfaces. Somewhere light rays are coming and they are going to fall on this medium. When they fall in this one, this medium allowing those light rays to pass through it is called as transparent medium. Transparent means through that light rays are passing. In detail later we discuss about that lens. Means it is optical medium which is allowing light rays to pass through it. See here. It's a biconvex lens. Here there is a midpoint, this one, that we call as optical center of that lens. The geometrical midpoint of that lens is called as its optical center. The geometrical midpoint is called optical center. Very important. See. If there is a mirror, then there we will be using pole, P-O-L-E, pole point. So here there is a plane mirror there. Again mirrors are of two types, concave mirror and a convex mirror. See here, just look here. It's a plane mirror. It's a plane mirror. See here, what I am going to do. See, this is, you just see, look on this one. It's a concave mirror, concave. And here one more is, it's a convex mirror. It's a concave mirror and this one is convex mirror. Mirror means one side is being reflecting and another side is non-reflecting. This shaded indicating non-reflecting. This side is reflecting. See, from here to here it is mirror, from here to here. The geometrical midpoint of mirror is called as pole, midpoint. From here to here, midpoint is this one. This we call as pole. The geometrical midpoint of mirror called pole. The geometrical midpoint of lens called optical center. Have you understood? Here also. From here to here, midpoint is here. This is P. See here, what I want to say. In this section, real image, here I have taken a lens. Here this geometrical midpoint is its optical center. Now, here I have taken this dotted line, a dotted line, which is passing through that optical center and center point. Here many things there, later we discuss them in detail in that section called lenses. Here just I tell, this dotted line we call as a principal axis. This dotted line we call as a principal axis. Getting what I mean to say? See. Now on that principal axis I placed one linear object, linear I mean their shape is looking like a linear body, has certain length. Here AB is a linear object, not a point object. There we taken this, I call as that point object. See like that. I mean, this is object. From that light rays are coming. It's a point object. It's object, point object. Here this is also object, not looking like a point. It has certain length, so we call it as a linear object. See, on that principal axis, I have placed AB linear object vertically upward with respect to principal axis. So now you see here, in front of that object we placed lens. From that object, light rays are moving in all directions. I have taken two light rays from their top portion. AB is an object. From their that top portion, I have taken two light rays. One light ray like this, that light ray is going to incident on that lens. Once it got incident on that lens, that light ray is passing through it and it deviating, it bending, it changing that direction. Instead of going straight, it bent. That we call as refraction. We'll see later. That light ray passed through the lens and it bent and it refracted. This is incident light ray, got incident on the lens and it bent, I mean it deviated in this direction. So we call this as a refracted light ray. Yes. That moved in this direction. Yes. One more light ray which is coming from the top portion of that object, which is passing through the optical center of that lens. A light ray which is passing through the optical center of lens is not going to deviate. It keeps its path straight. It continues its path. See here, this light ray coming and passing through the optical center, geometrical midpoint. So it continued their path. Even this light ray we call as a refracted light. Why that happened, we'll see later in detail. Now what I mean, these two are incident light rays, these two are refracted light rays. Those two refracted light rays got met here at this point. Getting what I mean say? What I meant to say? These two incident light rays, after refraction from that lens, they merged. I mean they got met here at this point. That intersection point we to call as an image. Here that point we call as image. These two refracted light rays, here they produce their image. Getting? Yes. See here. Now here they actually met with each other. These two light rays actually they met. There they produce image. That image we have to call as real image. Why we call as real? Because those refracted light rays are being there. They are actually going to merge. They are actually going to meet. So we call it as a real image. Really, that image is existing there. That image showing its physical appearance. Getting what I mean to say? See here, suppose, what I mean to say? Here they got merged, they got met. At that position, suppose if you place a screen, at that respective position, if you place a screen, on that screen you will be seeing the image of that AB object, which I named as A dash B dash. A dash B dash is image of object AB. Here at this intersection point, if you place a screen, on that screen you will be seeing like this vertically downward image of that object. Mean what? By placing screen you can able to get that image. Mean what? Their physical appearance is there. Mean what? Those two refracted light actually merged there. So they produced the physical appearance of that image. Such image we call as a real image. Are you getting what I mean to? Real image means that image we can see and even we can get it on screen. We can observe or we can get its physical appearance that is going to be there. We can see as well as we can get it on screen. Means we can have its physical appearance. Such image is called as real image. Have you understood? So real image means image which we can see and even which we can get on screen called as a real image. Have you understood? Yes. After this, next virtual image there. Already we discussed in previous class. Virtual means it looking like being there, but actually it not being there. We feel it is going to be there. As we go there, we can't get it. That's why virtual image means the image which we can see only, but we can, but we can't, but we cannot able to get its physical appearance. Such image called as virtual image. Well known incident as early morning. You going to stand in front of plane mirror. You going to stand in front of plane mirror. You imagine this marker is you standing in front of this plane mirror. This my hand is plane mirror. In front of that you standing. When you look onto this mirror, what you see? You see your image. You see your image in that mirror. You feel that your image is there behind that mirror. Somewhere behind mirror that your image is there. You feel like that. You standing here, you are an object from your body, light ray coming and bouncing back, and somewhere behind the mirror they produced your image. You can see that your image, but you can't get it on screen. Means what? When you go behind the mirror, you won't get anything. Behind mirror, you won't get anything. But you can see something is there behind mirror. You can see it is there. It looking like being there behind mirror. As we go behind, you won't get anything. Such kind of images are called as virtual images. The images which we can see but we cannot get them on screen are called as virtual images. So now the image which you see every day in mirror is called virtual image. You can see only, but you cannot say where you are behind mirror. Behind mirror, where you are, you can't find out. So you can't see your physical appearance of that image. So it's virtual. See, look on this diagram. Here diagrammatically I have shown that. Here again I have taken a lens, optical center, and this is a principal axis. So now in front of that lens I have taken again a linear object AB. This AB is a linear object placed in front of that lens, very near to it. Here I placed too far away, so we got real image. Here in this one I taken that object very close to that lens, so we got another kind of image. Why that happening? Later in those upcoming class we will discuss in detail. Now just you see what mean virtual. I placed the object very close to the lens. From that object again I have taken two light rays. One is this one. This light ray got incident on the lens and it refracted along this direction. Refracted light ray. And one more light ray which is coming, this one. This is incident. Two light rays. One came like this, got refracted like this. One more light ray which is coming from that top portion and which is passing through the optical center keeps its path continue, that not going to deviate. A light ray from any object passing through the optical center of lens, it won't change their direction, it keeps continue. Yes, this one and this one. These two are refracted light ray. You look here, you see here how they are. They are looking like diverging. Here in this one, they were looking like converging. They got met at one point here in this one. But here, they looking like diverging. This light ray and this light ray, they are diverging. So, they won't meet somewhere here because they are diverging. They are not going to meet somewhere here because they are diverging. So what we do in these such case, just we have to extend the direction of those refracted light rays in the backward direction. We have to extend the direction of refracted light ray. It's a refracted and this one also refracted. Their paths we have to extend in the backward direction. We have to extend the paths of refracted light rays in backward direction. They are like this. You go back. They looking diverging. If you go along their path somewhere, they are going to obviously meet. Yes. You see here, I extended this one like this and even extended this one also. Here they got met. Here they got met. These two refracted light ray by extending in backward direction they met here. There they going to produce their image. Here where they got intersected, there those light ray produced the image of that object AB. So now here A dash B dash. This A dash B dash is image. Which kind of image? It's virtual image. Why we call virtual? Because that A dash B dash, that image, we can see it being there. We can see it being there. As we go there and we keep the screen, will not get its physical appearance. As we go there and we'll keep the screen, will not get that A dash B dash on screen. But we can see. So we call it as a virtual image. Virtual, it looks like being there. But as we go there, as we keep the screen, we will not get it. Just only we can feel their presence, not physically. Such images are called as virtual images. Have you understood this? As I said, similarly, that plane mirror case. In that plane mirror case, you see your image behind mirror. As you go behind, you will not get anything, but you can see. Such images are called as virtual images. See here, there is a main difference there between real image and virtual image. Real image, the image which we can see and even we can get it on screen, means we can identify its physical appearance. Virtual object means object we can see, but we unable to get its physical appearance. The image which we can see but unable to get it on screen called as virtual image. Simple, real image we can get, virtual we can't get on the screen. This is about the object and images. After this, see here, I have written the law of rectilinear propagation of light. Law of rectilinear propagation of light. Propagation means movement. I said at the beginning only. From the source of light or from one reference point to another reference point. In that respective medium, light obtaining or getting a straight line path. Mean what? You see here, look on this diagram. Look on this diagram. Here I have taken two reference points. A is an initial point and B is a final point. From that A to that final point B, that light traveled by obtaining a straight path. By obtaining a straight path. This we call as law of rectilinear propagation of light. It states that light ray is moving along a straight line, in a homogeneous medium. In a homogeneous medium. What means homogeneous? Homogeneous means a medium in which their properties are same throughout its volume. Means what? You imagine this classroom as one medium. It has its own volume. Throughout its volume, the arrangement of molecules should remain same. I mean, property of this medium throughout its volume should remain same. Such medium we call as homogeneous. Homo means same. The arrangement of the molecules throughout its volume should remain same. Such medium is called as homogeneous medium. Means what? Look here, that light moving from A to B. A to B, one medium is there here. From A to B, here there is a medium. That medium should be homogeneous. Means what? That medium should be with the same arrangement of molecules. From here to here, the property of that medium which is present here should remain same. Suppose from here to here, air medium is there. The arrangement of molecules from A to B in that air medium should remain same. Then we call it as homogeneous medium. Suppose somewhere from here to here air is there, thereafter somewhere here water is there, then that light ray is not going to occupy the straight line path from A to B. Why? Because there is no homogeneous medium between your initial point and final point. Why? Because two mediums are there between that your initial and final point. Somewhere here air is there and thereafter water is there. That light ray changing their direction. It won't occupy straight line. Getting? That's what I mean. In a same medium, between any 2 points, that light ray moves along a straight line. That we call as rectilinear propagation of light. It states In a homogeneous medium, between any two reference point, light moving along a straight line. Have you understood? See, you can see in this diagram also, from A to B, light moved along that straight line path. That arrow indicating its direction. It moved from A to B. Yes, it's a very important. In exam, they will be asking this one for one more question. So concentrate on it. So next, after this one, come here on this one. Here, I have written linear magnification. I have written linear magnification. What it means? You see, magnification. Here in these two diagrams, what we see in front of that respective optical element, there an object, their image we got. Here in this chapter, I already said we are going to discuss about the interaction of light coming from so and so object with the optical elements to produce their respective images. In this chapter, what we are going to study? Interaction of light rays with optical elements to produce the images. I mean, here we are going to get the images of so and so objects. Object means it has its own dimension, it has its own size. After that, there we are going to get their image. That image also being with its own dimension. So there here in this section, in this magnification section, after getting image, if the size, I mean if the height of that linear object, if the height of that linear object is lesser than that, then we call that image is diminished. If the height of image is greater than that object height, then we call it as magnified or enlarged. So some words will come: diminished, lesser in size, magnified, greater in size. So here that size of image depends on the position of object in front of that optical element. The size of that size here means linear magnification. Linear magnification means we focusing on the height only, height of the object. Linear word telling along straight line. We focusing on height of object and height of image. See, they going to change. See here, the height of image depends on the location of object in front of that. In front of that. See here, we'll see that in detail with different positional objects. See now what I mean to say. Linear magnification. That linear magnification is telling us it is the ratio of height of the image to the height of the object. Here, thereafter getting image, whether it is diminished or magnified, to say that one, we go with a magnification. See here, that magnification telling it is the ratio of height of the image to the height of the object. Height of the image we are going to represent with h dash. That dash indicating image height. And the height of the object we indicating with small h. Small h, height of object, small h dash, height of image. This is about linear magnification. That we representing with the small m symbol. M is equal to h dash by h. This is general formula. This is general formula. This formula has its own form. I mean, it's going to get changed. This formula, it's a general one. For a mirror, it is different. Different means it's being with the sign conventions, whether it is positive or negative sign convention.